Welcome to the lecture on replacement analysis. So, in this lecture we will deal with some situations where replacement is because of inadequacy or because of obsolescence. So, we have earlier studied that because of these reasons like inadequacy or obsolescence, the replacement is suggested, and economic terms you have to evaluate the proposal's annual equivalent or present worth or the future worth, and then you have to come. Now, in this case of any inadequacy, as the name suggests that the company is not able to meet the demand which is now with the company, it has a unit which is having less capacity and it needs to install one more unit so that it supplements the existing unit, or it has the option to replace this just to dispose this present asset and take a new asset. So, the problem is that a building installed a generator 10 years ago at a cost of rupees 9,20,000 to provide the necessary backup. It had purchased this generator 10 years ago. Now, since there are more number of users, it is only able to fulfill 50% of the demand. So, it needs the similar rating of generator. The old generator has a salvage value of 3,60,000 and it is estimated that it can be used for additional 8-year period with annual operating cost of 2,80,000 and a zero salvage value at the end of that time. So, it means if we try to solve this problem, what we have is, we have old generator, it was purchased in 9,20,000, so it is gone, cost, it is a sunk cost, now its value is 3,60,000, so its present cost is 3,60,000. Life is 8 years and annual operating cost is 2,80,000. Salvage value at the end of the life is 0. Now, if the old generator is retained, a new unit with the same capacity will be purchased at a cost of rupees 7,20,000. So, basically you have to have a new generator because it is meeting 50% of the demand. So, this will meet 50% of demand. So, if the decision is to keep this unit, you need a similar unit which should satisfy the 50% of the demand, and this can be purchased at rupees 7,20,000. So, for this P is rupees 7,20,000. Service life is 10 years, salvage value is 1,20,000, and operating cost annually is 2,40,000. So, this is the one option. The first option is that you retain this old generator and take a new generator which will also supply 50% and your demand will be met. Second option is that you buy a new generator having the capacity of 2 small units combined. So, it will give you 100% demand fulfilled. it has initial cost of 12,80,000, new unit which has 100% capacity to fulfill the demand. It has P as 12,80,000. Life is 12 years. Its salvage value is 1,60,000 at the end of 12 years. And operating cost annually is 4,40,000. Now we have to suggest whether we should keep this generator and have a generator of half the capacity, or we should replace this and take the new generator. So it is suggested that the MARR is 15% and study period should be taken as 8 years. So study period taking 8 years means it is assumed that after 8 years you will have certain value to it, that is implied salvage value. This also had that, and in that case the annual equivalent basis of comparison looks to be okay. So we will proceed with finding the annual equivalent value, and the option with lower amount of annual equivalent will be suggested or will be preferred. So this is our plan 1 and this is our plan 2. Now in the plan 1, if we find the annual equivalent value for this, plan 1 for old generator, the annual equivalent will be P minus F. So salvage value is 0, so 3,60,000 into A by P I n, n is 8, so A by P, and interest rate is taken as 15%. In both the cases I is taken as 15%. This is the minimum attractive rate of return, so it will be 15.8 plus you have f into I, so that concept part is gone because f is 0. So this is the capital recovery with return part. Then you have annual operating cost, that is 2,80,000. So A by P 15.8 we can get from this table. A by P 15.8 will be 0.223. So this will be 0.223. In that case we will multiply this (80280) plus 280000, that is 360,280. Then now this is for the old generator which is giving 50%, and in the plan 1 the new generator which is giving another 50%. For that annual equivalent will be, you have P as 7,20,000, f as 1,20,000. So, P minus f, that is 6 lakh multiplied by A by P I n, n is 10 here. So, it will be A by P 1510 plus f into I. So, this is f is 1,20,000 into I rate is 0.15 and plus the operating cost annual is 2,40,000. A by P 1510, which is coming out to be 0.199. So, it will be 0.1992. So, once we get the values, 6 lakh multiplied by 0.1992 plus 18,000 plus 2 lakh 40,000, this comes out to be 377,520. So, this is the annual equivalent for the old generator, which will be giving 50% of the demand requirement, which will be fulfilling. Now, new generator fulfilling the 50% requirement is 3,77,520. So, total annual value will be 360,280 plus 377,520, and if we add that, it will be 737,800. This is the annual expenditure using 8-year study period for the option in which we try to retain the old generator. Now, if we find the annual equivalent for the new generator, that is plan 2, which is basically you are taking a new generator giving you 100% the demand requirement fulfilled, it will be 12,80,000 minus 1,60,000. So, it will be 11,20,000 P minus F multiplied by A by P I n. So, 15 I and n is here 12 years plus F into I. So, 1,60,000 into 0.15 plus annual operating cost, that is 4,40,000. A by P 1512, and for 12 it is 0.1845. So, if we compute the values, it will be 11,20,000 multiplied by 0.1845 plus 24,000 plus 4,40,000. It comes out to be 6,70,640. Now, what we see is in plan 1 we get the annual equivalent value as 7,37,800, and in the plan 2 we are getting 6,70,640. So, since the verdict is AEI for plan 1 is greater than AEI for plan 2, and this is about the cost incurred. So, it is better to buy new generator and dispose the existing one. Plan 2 is preferred. So, this is how, when we have the question regarding the problem where there is inadequacy and you are to decide whether to replace or not, we can deal with the problems in such manner. We will deal with the next problem. This problem is replacement because of the obsolescence. This problem says that the manufacturer plans to install a new equipment after replacing one of its present equipment with an aim that the new equipment will consume less energy and raw material. So, basically the existing equipment has become obsolete, it is consuming more energy, and the new equipment which is proposed, it will consume less energy and raw material. The present equipment in operation was purchased 5 years ago at a cost of rupees 40 lakhs and can presently be sold at rupees 14 lakhs. So, it means present machine's cost is 14 lakh. Because of the rapid obsolescence of the equipment, because of the arrival of new energy efficient equipment, the future salvage value of present equipment is expected to decline by rupees 1,60,000 a year. So, basically its salvage value will decline every year. If the present equipment is retained for one more year, its operating cost is expected to be rupees 26 lakh with increases of rupees 1,20,000 a year thereafter. So, operating cost is going to increase every year from 26 lakh by every year by rupees 1,20,000. New equipment will cost rupees 52 lakh installed, economic life is 8 years with salvage value of 4 lakh. After 8 years, annual operating cost is rupees 19,60,000. So, at 15% MARR, we have to suggest whether replacement is suggested or not. So, let us solve this problem. So, what we have is, we have plan 1 and plan 2. In plan 1 we have the old machine and here you have new equipment. So, old equipment and new equipment. Now, in this case it is said that your MARR is 15%. So, the common data is I is 15%. Study period for the new machine is 8 years and for the old machine it can be used. So, for the equivalent comparison we have to go for 8 years of study period. So that we can compare their values, equivalent values. So, we will take n as 8. Now, for the old machine we have seen that it was purchased in some cost at 40 lakhs, which is a sunk cost. So, it has nothing to do with this, its present cost is 14 lakh. So, it is P is 14 lakh. Now, future salvage value of present equipment is expected to decline by rupees 160,000 a year. So, basically if you are using it for 8 years, the future salvage value after 8 years will be 14 lakh minus 8 times 1,60,000. So, it will be 12,80,000. So, 1,20,000. Because we are taking the study period as 8 years, a comparative period for equal for both. So, after 8 years the salvage value will be 1,20,000 of this machine. Now, if it is retained for one more year, its operating cost is 26 lakh, and since it is kept for 7 more years, in the first year it is 26 lakh, but operating cost in the, so operating cost basically it is 26,000 in the first year, 26 lakh in the first year, and plus 1,20,000 increase every year. So, basically you can have its annual equivalent value. If you try to have the annual value, it will be nothing but, so annual operating cost equivalent value it will be nothing but, it is a geometric series, it is a basically uniform gradient series. So, you have 26 lakh plus this is the G. So, 1,20,000 A by G 15,800. Operating cost is basically that way. 26 lakh is the in this year, first year, and it is going every year increase by 26 plus 1 7.2 and like that. So, it is going like this up to 8th year. So, that is why we are getting the annual equivalent value of the operating cost as this amount, and A by G 15,800 we can get it from the table. A by G 15,800 will be 2.781. So, it will be 1,20,000 multiplied by 2.781 plus 26 lakh. It is 29,33,720. Now, further, if you try to find the annual equivalent value AEI, it will be P minus F. So, 14 lakh minus 140,000, that is 12,60,000 multiplied by A by P 15,800 plus F into I 140,000 into 0.15. So, that is 21,000 plus annual operating cost, that is 29,33,720. So, A by P 15,800, it will be 0.223. So, this amount will be plus 21,000 plus 29,33,720. So, it comes out to be 32 lakhs 35,700. Now, if we look at the plan 2, in that case we have P as rupees 52 lakh, and N is 8 anyway, salvage value is 4 lakh, operating cost is 19 lakh 60,000 annual. So, annual equivalent value will be P minus F, that is 48 lakh, A by P 15.8 plus F into I, so it is 60,000 plus operating cost annual 19 lakh 60,000. So, it is 0.223. So, we can get this value also, 48 lakh multiplied by 0.223 plus 60,000 plus 19 lakh 60,000. So, it is coming out to be 30 lakh 90,400. So, what we see is we have 30 lakh 90,400. In fact, there has been a mistake here. This 1,20,000 is the F. So, P minus F will be 12 lakh 80,000. So, it will be, instead of 12 lakh 60,000, it will be 12 lakh 80,000, and this will also be 1,20,000 multiplied by 0.15. So, it will be 18,000. So, if we add them, 12 lakh 80,000 multiplied by 0.223 plus 18,000 plus 29 lakh 33,720, it comes out to be 32 lakhs 37,160. So, what we see is the plan 1 gives you the annual equivalent cost as 32 lakh 37,160 if we retain the old equipment, and if we purchase the new equipment, the annual equivalent cost is 30 lakh 90,400. It means going for plan 2 is advantageous. AEI plan 1 is greater than AEI plan 2. Plan 2 is better, and so replacement is suggested, because it involves the cost to run. This is annual equivalent cost. That is why we will go for the option which gives you minimum cost. So, it is better in this case to change the old equipment and go for the new equipment, which is basically based on new technology consuming less energy, and that is why the replacement is suggested. So, this is how we solve the problems based on inadequacy and because of the obsolescence and so on. So, as you practice and practice, you will get more confidence on these questions. Thank you.